Example 4, write equations given characteristics. Write an equation and graph a parabola with a focus of 2, 1 and a vertex of negative 5, 1. Well, let's first plot those points and see what we're working with. If I plot the focus at 2, 1, that means right 2, up 1. I'm going to have this point here. There's my focus. And it says the vertex is left 5, up 1. So this would be my vertex. Now, if we wanted to graph this and write an equation, we could look at these 2 points and see what they give us. The distance from vertex to the focus is 7. That is our P. So we can state in this problem that our P is 7. Now, why does that matter? Well, if we're writing an equation, we are always given some parentheses squared equals 4P times another parenthesis. Well, if we know that P is 7, we could say that 4P is equal to 28. So we're given this information. Now, this, since it's the focus is to the right, the parabola always opens around the focus. So this will be a horizontal parabola. And not only that, this is 7. We just discovered that this value here would be 28. So this parabola would go up 14 units. So there would be a 14-unit space between there. And it would go down 14 units as well. So this would have a total distance of 28 at the point of the focus. That would be the latus rectum. It would be 28 units long that way. This is 7. So far we have that this is horizontal. Because it's horizontal, I'll put an X there, and I'll put the Y in this parenthesis. And this parenthesis needs to be squared. We could also state that it's shifted left 5. To be shifted left 5, we have to have a plus 5 here, and it's up 1. So I'll put a minus 1 there. There's my equation. And it's fully solved. The last thing, if I really wanted to graph this completely, is I could add in, if the focus is 7 to the right, if I went 7 to the left, 1, 2, 3, 4, 5, 6, and 7, we could add in a directrix here. And we could also add in the axis of symmetry. We could cut it in half. So you could add those to your graph, and that's what I have over here in this image. But really what we needed to find was the equation, and we had done so. Let's try another one. Part B, write an equation and graph a parabola with a vertex of 3, negative 2, and a directrix at y equals negative 1. So my vertex is going to be right 3, down 2. So there's the vertex. And the directrix is y equals negative 1. Now, when it says y equals negative 1, that means it's going to hit the y-axis at negative 1. So the y-axis at negative 1 is there. That's my directrix. I'll label that just so we can. That's y equals negative 1. Now, the parabola is always going to, if that's my vertex and that's my directrix, it will open the opposite way. And not only that, if there's 1 unit between the vertex and the directrix, we know there's going to be 1 unit between the vertex and the focus. So that'd be my focus there, and we could draw a parabola. If that's 1 unit, it'll be 4 units wide at that point. So if I went 2 to the left, I'd have a point, and if I went 2 to the right, I'd have a point. So my vertex, my parabola, rather, would look like this in this particular problem. And again, that's because this is 1 unit away, so this would be 4 units wide, because it's always 4 times it. So we just discovered here, our P, since it's going down, our P is negative 1. And if our P is negative 1, 4P is going to equal negative 4. So let's go up here. We are equation. We know we start with this. And we said 4P is negative 4. So I'm going to erase that, and I'll put a negative 4 right there. Now it's vertical, so the y goes here, and the x goes here. Where's my vertex? Vertex is right 3, down 2 units. So right 3 would be a negative 3, down 2 would be a plus 2. That would be my equation here. And if I really wanted to make this graph perfect, I would need to add the axis of symmetry. It should cut through this way. And that's how this image looks over here. And so now we have one more. Let's look at part C. It says this time the parabola has a focus at -1, 7. So we go left 1, up 7 units, 6 and 7. There's my focus. And it also says it opens up. So it's going to open around this focus going up. And it'll contain the point 3, 7. Which means if I go right 3 units, I'll find this point. Now, since that's in line with the focus, I know that this parabola that's opening up and hitting this point will also hit it over here. So if it was right 4 from that spot, if I went left 4, I would find another one. So if I go left 4, I get this other value. Now, this is equal to 4p. So 4p would equal, if we count them up, this is 8 units across. So it's 4 to there, 4 to there, so that 4p equals 8. That means that p equals 2. As far as the equation goes, I can put, we now know what 4p is, and so I can erase the 4p here and say that 4p is equal to 8. And since we know it's opening up, we could put a y there and an x there. Now, if 4p is 8 and p is 2, we could put on the vertex. That means that focus is 2 units up from the vertex. So the vertex should be located there. And it would have this shape to it, like that. And so my vertex is left 1, and it's up 5 units. And that would be my equation. Again, you could add the axis of symmetry and the directrix. Directrix would be 2 units down, which would be a 3. So the directrix would be in there, and the axis of symmetry would obviously cut it in half. And that's kind of what this picture shows here. Now I got one for you to try.